So this recording is going to be of the actual quiz that we did pretty poorly on. As a matter of fact, as a class average, we were like in the F range. So that's why we're going to see this again on the test Friday, and it could replace your previous score. So even before beginning with this exponential growth or decay quiz, let's go back and let's do some simple notes here, all right? We have y equals a times b to the power of x. And in algebra 2, you will have a minus h. That's why I put it in blue. But in algebra 1, we don't have that minus h, but we will have a plus k, all right? And there's many things to note about this exponential growth or decay function setup, y equals a times b to the power of x plus k. One thing to know is that the base right here, whatever's inside the parentheses, that's your growth or decay factor, okay? If that b is a value greater than 1, it's going to grow. That means that from left to right, it's going to grow away from the asymptote. So I just wrote down what I just said. If the value b is greater than 1, then from left to right, it will grow away from the asymptote y equals k. Remember that your asymptote, your horizontal line, is determined by that value that's being added or subtracted at the very end. All right, and we'll get to some examples right now. I just want to give a basic lesson before we actually go back and review the entire quiz. And we're going to be reviewing the quiz. Why? Because it's going to come out on the test, so we need to know this stuff. Let's talk about if b is less than 1, like a decimal value or a fraction that's less than 1. Okay, so if b is less than 1, let me actually highlight this. If b is greater than 1, then it's growth. If b is less than 1, it's a decay. From left to right, it will decay towards the asymptote y equals k. So y equals k is going to be a horizontal line that we call the asymptote. We need to know this, guys, so I hope you guys jot this down in your notebook. You guys understand it because you need to know it. Let's jump right into the quiz itself. So here's question 1. State the range. Okay, now let me actually just really show you this entire exponential growth function, everything that we know about this, all right? Let's not just state the range, let's state everything. Let's begin by, if I look at this base, it's a value of 3. That's greater than 1. What does that mean? Is this a growth or a decay function? It's growth. From left to right, it's going to grow away from the asymptote, all right? So this is a growth function. This is growth because b is greater than 1. B is 3, right? So it's growth. So that means that it's going to decay away from the asymptote. What is the asymptote? It's going to be y equals k, and k is the number that's being added or subtracted at the very end. So the asymptote is y equals 2. All right, so even though they're not asking us to graph, check it out. I'm going to graph it. I'm going to sketch it. I'm not going to graph it. I'm going to sketch it. Y is 2, so it's going to cross the y-axis at 2. And y equals 2 is this horizontal line. That's what we call the asymptote. Y equals 2. And then I know that from left to right, it's growing. So you could go to the asymptote, and from left to right, it's going to grow away from the asymptote. That's what we call a growth function. So this is just a sketch right here, guys. You could draw it like if it's actually touching, even though you know it never actually touches, just infinitely approaches, and then it grows. That is a good sketch of an exponential growth function, y equals 3 to the x power plus 2. What else could we state about this thing? How about the Y-Intercept? Do you guys remember how to find the Y-Intercept in Algebra 1? In Semester 1? You set x equal to 0 and then solve. Okay? So if I take my above function, y equals 3 to the x plus 2, and I set that x equal to 0, it's going to read y equals 3 to the 0 plus 2. And we should know from the previous lesson of exponents, anything to the 0 power is 1. So you really have 1 plus 2, which equals 3. So the y-intercept really is 3. What does that mean that the y-intercept is 3? That it's going to cross the y-axis, not at 1, not at 2, but at 3 right there. So that's a good sketch. it crosses the y-intercept, it crosses the y-axis at 3. Okay. What about the domain? Like I said, I'm taking this function and I'm going to state every detail I can about it. When I say what is the domain, I'm talking about the x values, and we do see that it does go to the left forever, and we do see that it goes to the right forever. Even though it goes up, it'll still exist over here, but just way up there somewhere. It'll still exist over here, just way up there off the graph somewhere. So it really does go to the left and to the right forever. So the domain is x equals all real numbers, and the range are your y values. And we could clearly see that this graph is above that asymptote value of y equals 2. Even though we draw it like it touches, we know it never actually touches, it just infinitely approaches. So that's going to be y is greater than that k value of 2. That's all there is to state. Now, on this particular question, it said state the range. That's just this guy, y is greater than 2. That would be this answer right here. Y is greater than 2. I'm sorry, I explained way too much for this one simple question. But if you understand everything, you'll be able to answer everything, right? So look how easy the other questions are going to be, since we already reviewed everything that there is to know about exponential growth or decay functions. Well, number 2. Which of the following variables is the growth or decay factor in y equals a times b to the x plus k? In other words, which letter will tell you if it's growth or decay? The answer is B, right? B will tell you if it's a growth or a decay function. B will tell you if from left to right it's growing away from your asymptote, y equals k, or if it's infinitely getting closer to your asymptote, decaying towards your asymptote, y equals k. The B value, if it's greater than 1, it's going to grow. If it's less than 1, it's going to shrink, it's going to decay. So the B tells you if it's a growth or decay, and it's that simple. That's your answer, B. Whoops, I scratched it out instead of highlighted it. Here we go, B. Option C is the answer. B is the growth or decay function factor. That'll tell you if it's a growth or decay. Number 3, state the y-intercept. Oh, I remember how to find the y-intercept. How do you find the y-intercept? You set x equal to 0, then solve. Okay, so let's look at the entire exponential growth function. How do I know it's growth? Because there's a 3 right there. It's bigger than 1. And let me find the y-intercept by setting x equal to 0 and solving. So I really have a y equals parenthesis 3. Instead of x, I'm going to plug in that 0 that I'm saying, set x equal to 0. I plugged it in right there. Then we have a plus 2 at the very end. So we should all know that 3 to the 0 is 1, and 1 plus 2 equals 3. So your y-intercept is at 3. Now let's think about what that means, that your y-intercept is at 3. This is your y-axis, this is your x-axis, 1, 2, 3. This is where your line will cross the y-axis. What is that location? It's the location 0, 3. And as you could see, none of these are 0, 3, so you should select option E. None of these are correct. Let's move on to question 4 on the quiz. By the way, when I say question 4, it might not be question 4 when you take the quiz or when you took the quiz, because it automatically scrambles up all the questions. Question 4 reads, which of the following equations represents this graph? Well, let's just look at this graph. Let me ask you this. Is it a growth or a decay function? And how do you answer that? From left to right, does it grow away from the asymptote, or does it decay infinitely towards the asymptote? So is this a growth or a decay function? Go ahead and type it in. Decay is the correct answer, because from left to right, it's decaying towards the asymptote, y equals k, and we should see that that k value, the asymptote itself, is the x-axis in this case, which is the y equals 0 line. Now, what do I mean by it's decaying towards the asymptote? Check out this distance from that red dot to here. That's a pretty big distance. We're talking about 1, 2, 3, 4, 5, 6, 7, 8. And then from here to the asymptote, that's only 3. And then right here to the asymptote, that's 1. And then that's like, I don't know, 1/2 or 1/3. It's less than 1/2. And then it's closer and closer. And we know that it infinitely gets closer but never actually touches. We know this is a decay function. So what does that tell us? That tells us just on what we've talked about, we know that there is no k value that's being added or subtracted at the very end. So option C has a k value. That's saying, I probably should have done it in green since we always do k values in green. That's saying that the asymptote is at y equals -2, and we know that that's not the case. We know the asymptote's at y equals 0. So that will automatically eliminate option C. That can't be it. We did say it was a decay function, which means that from left to right, it's decaying towards the asymptote, which means that the base has to be a value less than 1. So that means it cannot be this guy, because that one's greater than 1. Can't be that. That's a growth function. It can't be this one either, because that's a growth function. So this is the only one left that could work. Now, yeah, it could be none of these. So what should we do? We should go back to the graph itself, and let's plug in, or actually we could do this. Go to this possible function, y equals 1/3 x, and you can make a quick xy table and just plug in a value. Like, let's say, if you plug in 1, what do you get out? Well, 1/3 to the 1 power is 1/3. So if you have a coordinate at 1 and 1/3, then you know you're good. And if we do go to the coordinate 1, and that is 1/3 of the way up, it's not halfway up, it's less than that. So you could assume that that's 1/3. It looks like it's the right graph. Now, of course, if you wanted to really be absolutely positive, you could plug in the input of -1 and see if it gives you the output of 3, because that's a coordinate right there, -1, 3. So check it out. If we did plug in a -1, would it give us 3? And the answer is yes, because when you plug in a -1 right here, that'll be 1/3 to the -1 power, which means that you have 1 to the -1 over 3 to the -1, which means you'd have to switch that one down and switch this one up, and that would give you 3 to the 1 over 1 to the 1, which is really just 3. And that is the coordinate on the graph. But that's like really, really making sure, like it's pretty clear that B is the correct answer, okay? Let's move on to number 5. Number 5, which of the following equations represents the graph above? Find the y-intercept. Finding the y-intercept will help. So let's first take a look at this guy. And is this a growth or a decay function? So as you can see, I drew that horizontal line. That's the asymptote. And you guys are telling me that the asymptote is y equals 1. Okay, that's great. That's awesome. And we could use this because the asymptote is the k value that's being added or subtracted at the very end of the function, right? So I just asked you guys if it was a growth or a decay function, and a lot of people are saying growth, but some people are still saying decay. From left to right, what happens? You see, I'm over here, and I'm going to the right. It's really close to the asymptote, but as I go this way, it grows further and further and further away from that asymptote. So this is definitely a growth function from left to right, which means that the base has to be greater than 1. On my y equals a times b, that base has to be greater than 1 because it grows away from the asymptote. So let's look at the options that we have down here. B has to be greater than 1, so we know it cannot be this guy. So you could scratch out C, that's a value less than 1. C is a decay, all the rest of them are growth, that is true. What else do we know about this graph? We said that the y value, the k value, was the asymptote y equals 1. So you have to have a +1 at the very end, which means that it could be A, it could be B, it cannot be -1, because that would be the asymptote y equals -1, so it can't be D. So we're down to 2 options. So on the instruction itself, it says tip, find the y-intercept, right? Let's find the y-intercepts of both of these. How do you find the y-intercept? You set x equal to 0 and solve. So on this first one, you'll have 2 to the 0 plus 1. And we know that 2 to the 0 is really 1. So you really have 4 times 1 plus 1, which is really 4 plus 1, which is 5. So the y-intercept is 5. Does the graph cross the y-axis at 5? Here we are, 0, 0, 1, 2, 3, 4, 5. Boom. We know this one has the y-intercept of 0, 5. We know that that's the right option. Okay. If I try to do the y-intercept right here, this one will be 2 to the 0 plus 1, which is really 1 plus 1, which is 2. And we know that it does not cross right here at 0, 2. So you could identify your graph, or your function, by doing the process that I just did, which is option A, not any of the rest. Moving on. So what outputs would correspond to the inputs -3, -2, -1, 0, 1, 2, 3 using the function y equals 8 times 2 to the x? Well, guys, if we were graphing, what were we doing? We were coming up with the xy table, and I did ask you to please use consecutive integer inputs the way I have right here, -3, -2, -1, 0, 1, 2, 3. So -3, -2, -1, 0, 1, 2, 3. And then what did we do after that? We would use the easiest input, 0, and we would actually plug it in right there. 2 to the 0 is 1, and then 1 times 8 is 8. So we're going to put an 8 right here. The input 0 gave us the output 8, and that was pretty easy to do. So what I'm going to do now is use the base, which is 2, which means that it's going to grow, and I'm going to make this output 8 grow by that growth factor of 2. 8 times 2 is 16, times 2 is 32, times 2 is 64. Now, if I go backwards, if going this way it's times 2, going backwards it's dividing by 2, which is really multiplying by half. 64 times half is 32, times half is 16, times half is 8, times half, 8 times half is 4, times half is 2, times half is 1. And ladies and gentlemen, you could see your blue outputs here. 1, 2, 4, 8, 16, 32, 64. There they are. 1, 2, 4, 8, 16, 32, 64. This is the correct option. I hope we see that. I hope we understand that. Okay? If you don't, hopefully now you understand it, and when you see it on the test Friday, you get it right. It's pretty easy to do. Moving on to number 7. Same exact type of question. It just has a different function. Same exact inputs, because like always, I would want you to graph this by doing an input-output table and doing consecutive integer inputs. And I always say use the easiest number, which is 0. So when you plug in 0 right there, anything to the 0 power is 1, so you get out a 1. That's your output. And then you could get your other outputs by using the growth or the decay factor, in this case the growth factor of 2, to get to your other outputs. So 1 times that growth factor of 2 will give you 2 to get to your next output. Times 2 is 4, times 2 is 8. Now going backwards, instead of multiplying by 2, we're going to be dividing by 2, which is really multiplying by half. 8 times half is 4, 4 times half is 2, 2 times half is 1, 2 times half is 1, 1 times 1 half is 1 half, 1 half times 1 half is 1/4, 1/4 times 1 half is 1/8, and there we go. So let's look at the outputs, 1/8, 1/4, 1 half, 1, 2, 4, 8. That's our answer. 1/8, 1/4, 1 half, 1, 2, 4, 8. Option B. So jumping to number 8, it's select all the following true statements. So this says that it's a decay function. And we know that the base is 2, which is greater than 1, which is not a decay function, it's a growth function. So this one's obviously false. Do not pick that one. This says this has a y-intercept of 1/2. Well, let's find the y-intercept of this function. How do you find the y-intercept? You set x equal to 0 and solve, right? So let's do exactly that. We have 1/2 times 2 to the power of 0. And when we work this out, we'll get 2 to the 0, which is 1, right? 2 to the 0 is 1. So you really do have 1/2 times 1, which really is 1/2, which means that this guy is a true statement. This has a y-intercept of 1/2. When we set x equal to 0, and when we solve, we get 1/2, which means that the y-intercept is 1/2. Now, the asymptote of this equation is y equals 2. Remember, the asymptote is the equation y equals k, where k is the number that's being added or subtracted out here at the very end. And as you can see, there is no number added or subtracted out there at the very end. It does not say plus 2, right? If it said plus 2, then yeah, the asymptote would be y equals 2. But it says plus 0, which means that the asymptote is y equals 0, not y equals 2. So this right here is wrong. So don't pick that one as a true statement. Also, this one says from left to right, this graph will grow away from the asymptote. And that is true. If I'm on an xy plane, and we know that the asymptote is the y equals 0 line, which is the x-axis itself, and we know that the base is 2, should have done that in blue. The base is 2, which means that from left to right, it'll grow away from the asymptote. So over here at the left, it looks like it's touching. Then all of a sudden, it's going to grow away from the asymptote. And that's exactly what this one's saying. From left to right, this graph will grow away from the asymptote. And why is that? Because the base is 2, which is greater than 1. So if it's greater than 1, it'll grow away from the asymptote. If it's less than 1, it'll grow towards the asymptote. And of course, none of these are correct. That's not an option because we already saw 2 of them that were correct. Moving on to number 9. Ladies and gentlemen, we've been talking that the growth or the decay will be determined by your B value, the value that's your base. If your base is greater than 1, it will grow. If the base is less than 1, it'll decay. So it's saying which of the following are exponential decay functions? Well, this base is less than 1, so that's a decay function. This base is less than 1, that's a decay function. This base right here is greater than 1, that's a growth. So you don't want that one because they're asking for decay ones only. Actually, yeah, decay ones only. And this last one, 3/2, that's 1.5. That is a growth, not a decay. So that's not it either. So the only answers for decay are A and B. I hope we understand. I hope we get that. Number 10, which of the following are exponential growth functions? So how about this? I want you guys to type in on the comments which ones you believe are exponential growth functions. But that is correct. C and D are the only exponential growth functions. Why is C and D growth? Because this is a base that's greater than 1. That's going to be it's going to be growing very slowly, but it's still going to be growing. This is definitely greater than 1. 5/2 is 2.5. This is not greater than 1. That's not greater than 1. So the only growth functions are with the base greater than 1, C and D. It cannot be A, cannot be B. I hope we understand that. Moving on. Which are exponential decay functions? Okay, so a decay function from left to right will decay towards the asymptote. And we could clearly see that the asymptote right here is y equals -3. So from left to right, look, right here it looks like it's touching the asymptote. As I go to the right, am I getting further away? Am I growing away from the asymptote, or am I getting closer to the asymptote? It is obvious I am growing away from the asymptote. So this is a growth function. And I think they want us to find the decay functions on this one. So this one is definitely not it. That's not a decay. This one is a decay. From left to right, it's getting closer and closer and closer. It's decaying towards the asymptote y equals 1. Hope you guys see that. This distance from there to there is pretty far, but as you go from left to right, it gets closer and closer and closer and closer, closer and closer to the asymptote. So that's a decay function for sure. This one's one of the answers. This is also a decay function. I know you're thinking, wait, it looks like it's growing. Yeah, but from left to right, it's getting closer and closer and closer. It's not growing away from the asymptote. It's decaying towards the asymptote. So from left to right, if it's growing away from the asymptote, it's a growth function. If it's decaying towards the asymptote, that's a decay function. So this one's also a decay function, so this is a correct answer as well. This one as well is a decay function because from left to right, it's growing closer and closer and closer to the asymptote y equals 4. So from left to right, it's infinitely approaching that y equals 4 value, that y equals 4 limit. So this is also a decay function. It decays towards the asymptote from left to right. So I hope we understand that. From left to right, if your graph grows away from the asymptote, it's growth. If it decays towards the asymptote, getting closer and closer and closer, it's a decay. So just right here on the side, quickly, extra practice. Let's say my asymptote's down here. And let's say I'm way up here, and what's happening? Is this growing or decaying towards the asymptote? What do you guys say? Growth or decay?
Decay.
Decay, thank you very much. What if my asymptote, well, I think I messed up right there. What if my asymptote was right here? And let's say I had my graph going like this. From left to right, what's happening? Is that a growth or a decay function from left to right? It's growth. Thank you very much. It is growth because from left to right, it's growing away from the asymptote, which is probably like y equals 1 or y equals 2. Anyway, I hope we get that because, as you see, it is part of our quiz. Which of the following are exponential growth functions? Well, I guess I didn't get that whole thing. Let me check on the other page. Okay, because this question got cut off, I apologize. I don't know. I've had some technical issues here, but we need to describe or find out, state which ones of the following are exponential growth functions. So it's this simple. If from left to right, it grows away from the asymptote, that's what we call a growth function. So this is definitely growth. Why? The asymptote is up here, y equals 4, and this from left to right grows away from that asymptote. So that's a growth function. Okay, and the question here says which of the following are growth functions? So that's a growth function. This one's a growth function. You see, from left to right, here's the asymptote. From left to right, it's growing away from that green line from the asymptote. So that's also growth. Okay, if we look at this next one, that's also growth because in this case, the asymptote is the x-axis. And from left to right, we look at graphs the way we read sentences from left to right. It grows away from that green line. Right here, our green line is the x-axis, and from left to right, it grows away from that green line. So, and down here also, the green line is y equals -1. From left to right, it grows away from that asymptote. So technically, every single one of these are growth. A, B, C, and D. Oh, wait a minute. Glitch. Yeah, here's the glitching I'm talking about. A. Yeah, both are the same. They're both growth. Growth, 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 growth. They're all growing away from the asymptote from left to right. Jumping to the last couple of questions. Number 13, what is the range of the above graph? Well, we need to look at the range, and the asymptote is clearly right here, which is y equals 2. And this whole graph is, even though it looks like it's touching, it never actually touches, and it does grow away from that asymptote. So we know it never actually touches. It infinitely approaches as you go this way, but it never actually touches. So we know it's a growth function, but they're not asking whether it's growth or decay. They're asking for the range. The domain is all real numbers, but that's not what they're asking for. They're asking for the range. The range is y is greater than 2. You cannot say greater than or equal to 2. You just say y is greater than 2. And that's what you're supposed to type in, actually just this right here. Y is greater than 2. Because this whole graph is above the green dotted line. Last two questions. Select all the true statements. I love these, right? It makes you really think. When you're graphing an exponential growth function by hand, you should use consecutive integer inputs like -3, -2, 0, 1, 2, 3. Absolutely, right? Whenever you graph, you want to make an XY table by hand and use, most of the time we use these numbers. It's a great idea to use consecutive integer inputs. That way you could plug in your easiest number 0, and whatever you get out here, you could look at your growth factor to get your other answers. Like if your growth factor is 2, you'd multiply by 2, get a 4, times 2, get an 8, times 2, get a 16. Or if your decay factor is 1/2, then you'd multiply this by half to get 1, to get 1/2, to get 1/4. So yeah, that is a good idea when graphing an exponential growth function by hand. You should use consecutive integer inputs like those. -3, -2, negative. Oh, wait a minute. Technically, I have a missing -1 right there. That was my bad. But hopefully you understood the concept here that you should use consecutive integer inputs. So I forgot to put the -1. I apologize. I'll fix that on the actual test coming up. How about the next one? The asymptote is the line that your graph will infinitely approach but never actually touch. That is also true. That's also true. Y equals k is the asymptote, and that is the line that your graph will infinitely approach but never touch. And that's what this next one says. The asymptote is y equals k. That's absolutely right. If you have like y equals 1/2, let's say the base is 2 to the x and then -3, and this is just an example, right? Your asymptote will be y equals -3. It's based off of this number at the very end that's being added or subtracted. The next option reads, the domain of any exponential growth or decay function is x equals all real numbers. That is absolutely true. That's a true statement as well. Man, everything's been true so far. Obviously, that would mean that E, none of these are correct. That's not true. So you would select A, B, C, and D. But let's talk about D a little bit more. The domain of any exponential growth or decay function is x equals all real numbers. Let's go back to a previous question. So on this previous question, we had to identify which ones were growth and decay. And the reason why I put it here is just so we could look at it. And we know that this guy, that's a growth function, yeah, from left to right, it's growing up away from the asymptote, but it also has it going to the left. So it goes to the left forever and it goes to the right forever. Even though it looks like it goes up, it does go up, but it never goes straight up. In other words, this graph will exist somewhere over here, but way off the graph, off the screen. So the domain of a growth function, the domain is x equals all real numbers. And it doesn't matter if it's a growth function or a decay function. This one's a decay function. From left to right, it's decaying towards the asymptote, and you could clearly see that it'll continue to the right forever, and it'll continue to the left forever. Even though it's way up there, it exists to the left as well. So it does exist to the left and to the right, which means that your domain is x equals all real numbers, even on decay functions. It doesn't matter if it's a growth function or a decay function, x will equal all real numbers when it comes to the domain. So that's a true statement. Anyways, guys, let's move on to the last question here. Select all true statements. All exponential growth functions from left to right infinitely approach but never touch the asymptote. That is false. A growth function from left to right will grow away from the asymptote, not approach the asymptote, so that's not true. None of these correct? I don't know. Let's keep reading here. The range of y equals 2 to the power of x minus 3 is y is greater than -3. Well, if we think about this, we know that the asymptote is at y equals -3. So let's do a quick sketch. -1, -2, -3. So here's my asymptote, and we know that this is a growth function because the base is greater than 1. So from left to right, it needs to grow away. So from left to right, it's going to grow away from the asymptote. And because there's no negative sign out here in the front, it is opening, or it is going up. If there were a negative out here in the front, it'd be going down. So yes, this is true. And you could even make an XY table, input-output table. You could use consecutive integer inputs. You could plug in 0, and you could use that growth factor to find other coordinates. And you will get a graph that's similar to this sketch. And anyways, the range are your y values. And we could clearly see that the entire red graph is above the y value of -3. So that would be y is greater than -3. So that is definitely true. Moving on, y equals a plus b to the x plus k. Y equals a times b to the x plus k. Wait, I'm not even reading this right. Oof, it's been a long video, I apologize. If b is any fraction, if this value is any fraction, then it must be exponential decay. That's false, because this could be a fraction that's greater than 1. It could be 3/2, and that'll be 1.5. And anything greater than 1 will cause us to be a growth function, not a decay function. So right here it's saying that if you have any fraction, if this is any fraction, it must be decay. That's false because it could be a fraction that's greater than 1. So we're going to cross that one out. And there's 2, none of these are correct. Wow, that was another typo and my bad, I apologize. So obviously C is the only correct answer there. So we've gone through every single question on this quiz. You will see pretty much these identical questions on the test that we have on Friday, as well as some simple questions with regards to rules of exponents, like x to the second times x to the third, that's x to the fifth. Or like x to the second time, or to the power of 3, that'll be x to the 6th, right? Simple rules of exponents. So I hope this video helps. Please let me know if you still have questions.